All right, so these are the notes for solving polynomial equations, day 1. All right, so here it says we're going to find the solutions and zeros. So you have used the zero product property to solve factorable quadratic equations. You can extend this technique to solve some higher degree polynomial equations. So here's an example here. So this one's pretty straightforward. When you're solving by factoring, it's what we've been doing, except now we're going to set them equal to 0 and solve, okay? So here, if you go through the steps, the first step is it in standard form? Well, we have 3, 2, 1, and no constant, so that's fine. Yes, it is in standard form, the polynomial. Second step is there a greatest common factor? Well, I see all terms are divisible by x. So I'm going to factor out of that, and I'm going to divide each one by the x. There was no coefficient in common, it's just the variable x. So x cubed divided by x is x squared. Negative 4x squared divided by x is negative 4x. And then negative 5x divided by x is minus 5. All right, from here, we can now perform the x method to see if we can further factor this trinomial. So my b is negative 4, my a is a 1, and then negative 5 times 1 is negative 5 for a times c. So my factors that add to negative 4 and multiply to negative 5 are going to be 5 and 1, with the 5 being negative. So now we have x times, this is negative 5, so x minus 5. This is 1, so x plus 1. Now we're going to set this equal to 0 because it does say for us to solve. So now I'm going to set each one equal to 0. So x equals 0, x minus 5 is equal to 0, and x plus 1 is equal to 0. So for the first one, it's done. Like, I cannot do anything further than that. For the second one, I'm going to add 5 to both sides, and I come up with x is equal to 5. And for the next one, I'm going to subtract 1, and we get x is equal to negative 1. So here I'm going to write all my solutions as 1s. I can keep it like this, but I'm going to write them in numerical order. So negative 1, 0, and 5 are my 3 solutions. For the next thing, we're going to take a look at graphing these, okay? So it says when a factor x minus k of f of x is raised to an odd power, the graph of f crosses the x-axis at x equals k. So the graph of x crosses, okay? So pretty much like, you know, if you have like x to an odd power, x cubed, x to the 5th, and so on, that's your odd power, it's going to cross through its intercept on the x-axis. When a factor x minus k of f of x is raised to an even power, the graph of f touches the x-axis but does not cross the x-axis at x equals k, okay? So to kind of summarize what this says here, and this is what we tend to use more, is that if you have an even, I guess for an even exponent, you could have like, you know, x squared, x to the 4th, x to the 6th, and so on. So to summarize what these two mean right here is if you have an even exponent, you're at the line when it comes towards it, when the graph approaches, it's going to touch the x-axis and turn, so touch and turn. All right, if it is an odd exponent, it crosses the x-axis. Okay, so let me go ahead and give you an example, okay? So I'm going to give you one that's already been factored out completely. So let's say we have x times x minus 5 times x plus 1. All right, so we made them all odd, right? So if we were to get our solutions, right? So here are my x-intercepts. So my x-intercepts for this would be x is equal to 0, x is equal to 5, and x is equal to negative 1, okay? Then we'll talk about multiplicity. So let's talk about what multiplicity is. Multiplicity pretty much means what is the power, right? How many times does it occur? So if you look right here, this is x to the first power, so the multiplicity for x equals 0 is 1. For this one at 5, it also has a power of 1, so that multiplicity is 1. X equals -1 also has it, so it's a 1. Okay. Now, if I made this a square, then the multiplicity for this would be at 2. So we're going to put a 1 right here. Next thing, now what does it do? So what's the behavior of this now? So the behavior, if you notice, the exponent is odd, so it's going to cross. The exponent for this one is a 1, so it's odd, it's also going to cross. And last, for the same thing, it's going to cross. So if you were to graph this on an x-axis or an xy coordinate plane, we're just going to plot our roots. So my root is at -1, 0, and +5. So this is just a rough sketch. Now, things that you can actually do is, if you recall in behavior, right? This is x times x times x, which is x to the third. So if you think about the in behavior, it's positive and odd, so the graph would look something like this. So we know we're going to start from the bottom left here. We're going to come to this, and we approach -1, and it tells us to cross. And we come back down to the root. At 0, it tells us to also cross. And then last, we come around, and we come back up to this, and we cross at 5 as well. And there you go. That's how you would use this information to make that graph. All right, so let's take a look at an example of this, but you might want to keep these by you. All right, so it says to find the zeros of f of x equals -2x to the fourth plus 16x squared minus 32, then sketch a graph of the function. All right, so for this one here, what I am going to do, let's go ahead and factor this. So the first thing I'm going to do is I'm going to look for, is it in standard form? Yeah, we have 4, 2, and a constant. Next thing, I'm going to look for a greatest common factor. So in this case, I see they're all divisible by 2, and I want to make it -2 because I want my x squared to be positive. And these are the only ones with x's, so it's just -2. So I'm going to divide each one of these terms by -2. So -2 divided by -2 is 1, so that's x to the fourth. 16 divided by -2 is -8x squared. And -32 divided by -2 is +16. At this point here, you can do the x method, or if you can see that it's a different to a perfect square trinomial, you can do that. But let's go ahead and factor it just so you can see what's happening. So I see -8. My a value is 1. And then 1 times 16 is 16. So my factors that add to -8 and multiply to 16 are going to be -4 and -4. So this is going to give me -2. Now, this is how we would originally write it. We would write x minus 4 and x minus 4. But if you take a look, x times x is x squared, not x to the fourth. So to fix this problem, all we have to do is square each of these x's. And once we square that, x squared times x squared is x to the fourth. And if you work it out, x squared times -4 is -4x squared. -4 times x squared is also -4x squared, which adds up to -8x squared. So by adding those two squares, it does work out. All right, now one thing I want to point out, we're still not done with this because when I look at these two, they're actually both difference of two squares, okay? So if you recall the formula, a squared minus b squared, so let me just work out one over here separately so you can see it. So I take the square root of this, which is x, and I take the square root of 4, which is 2. I'm going to write that twice. And like the formula, one's going to be positive, and one is going to be negative. So this factors out to that. So now we actually have -2. We have x plus 2. Sorry, I wrote a plus there instead of a minus. X plus 2, x minus 2, and that's happening twice because there's two of them. X plus 2, x minus 2. And last but not least, we're going to make sure that there's not multiple ones. So x plus 2 and x plus 2, we're going to write that as x plus 2 squared. And x minus 2 will be x minus 2 squared. All right, so it does want us to find the zeros, which are to find the solution. So what I'm going to do is I'm going to set each thing that has x, set it equal to 0. So for this first one, we're going to say x plus 2 squared is equal to 0. And for this one, x minus 2 squared is also equal to 0. So for the first one, when I solve it, I take the square root of the square and the 0, which gives me x plus 2 is equal to 0. We take away 2 from both sides, and our first root is going to be at x is equal to -2. For my second one, I'm going to take the square root of both sides again. And this one gives me x minus 2 is equal to 0. Then I'm going to add 2 to both sides, and my solution here is x is equal to 2. All right, last but not least, let's go ahead and graph this here. All right, so let's go with the x-intercepts first. So my x-intercepts, my multiplicity, and my behavior at the x-axis. Okay, so I have two solutions. My first one is at x equals negative 2, and my second one is at x equals 2. Now remember, multiplicity is dealing with the power. So if we go back and refer back to this, x plus 2 was x equals negative 2, but the multiplicity is this small number right here, so the power is 2. And over here, again, we have a power of 2, so the multiplicity is 2. So when we talk about whether that's even or odd, well, 2 is obviously an even exponent, so it's going to touch and turn. And the same thing with this one. This one is also even, so we're going to touch and turn. And if the multiplicity was an odd number, like 1, 3, 5, it would cross the x-axis. Okay, now from here, last thing I'm going to do is just make a rough sketch. So I have my solutions here, because that's what it asked me for. And now I'm just going to make a rough sketch of what it's going to look like. So I only have two solutions, negative 2 and positive 2. I know that's a little bit off, but it's fine. Actually, let me fix that a little bit. That's a little bit too far off. Let's try to keep the same distance. How about right there? Okay. Now, I'm going to go back to the very original problem just so I can kind of get a rough sketch of what it should look like. So it's a negative leading coefficient and it's even. So if you recall in behavior, your graph's going to look something like this, where it's facing down, and both of them. So if we start below here, when we approach negative 2, we're going to touch it and turn. So we touch it and turn, and we come down. Now, there is a way you can find the y-intercept and find where it actually comes through on this, and then you come back up, and you look at your next one, x is equal to 2, you touch it and turn, and it faces down. So you'll notice the end behavior facing down does work out, and this is my graph, rough sketch of what it should look like.